Welcome back to the SPSS series, and in this video we'll be picking up from where we left off. So we managed to upload our Excel sheet in SPSS, and this is what it looks like. In the previous lesson we explored how to download the software and install it successfully on your device, but now we'll focus on how to set up your variables in readiness for analysis. So before you can proceed, you have to make sure that you define your variables. So you simply click on variable view and you'll notice that there are several columns here, and each row in this case represents your different variables. So to begin with, there are various columns, but we'll focus on the most important ones. We'll start with the label. So the label allows you to write the full description of a variable. For example, if the variable here is age, you can simply type age of participant. So this allows you to simply write a description of the participant, and it affects your data analysis in no way, really. Then the next thing we'll look at is the values. The values column is used to assign meanings to coded numbers. So in this case, once you click on a value, you can choose to type up what the variable means or what the coding means. For example, what does 0 mean? What does 1 mean? For instance, on sex, we had male and female coded as 1 and 2. So you can simply add those labels here to make it easier for you in case you forget what each of those codings mean. As for the measure column, the measure column tells SPSS the level of measurement for each variable. There are three options in particular. There is the nominal, which is simply a variable that is in categories with no order. For example, sex, religion, province, blood group. Then the next one is ordinal. So ordinal variables have a natural order, but the difference between categories is not equal. For example, poor, fair, good, excellent, or strongly disagree, neutral, agree, or strongly agree. And then scale is used for numerical measurements. For example, age, height, weight, BMI, income. So where age is concerned, you need to put a scale. So once you have defined your variables clearly, it's time to analyze. So most statistical analysis in SPSS are found under the Analyze menu. This menu contains a wide range of statistical tools, but in this course we'll focus on three of the most commonly used analysis: the descriptive statistics, correlation, and regression. So let's look at each one individually, starting with descriptive statistics. Now, descriptive statistics are used to summarize your data. So they answer questions like, what was the age range of the participants? How many males and females are in the study? What's the highest or lowest value of something? Or how is the data distributed generally? And some of the descriptive statistics include the frequencies. We also have percentages, means, median, mode, standard deviation, and minimum and maximum values. So you can access these by going to the Analyze and then descriptive statistics. Then you can choose one. So in this case, we can decide to go with descriptives of the data. So when you reach this point, you want to select the particular variables that you'd want to analyze. So in this case, you can select, for instance, the age, sex. You can leave out the participant ID, pocket money, foods bought using the pocket money, why these foods were bought. Once you click that, you select OK, and another window will pop up showing you the descriptive statistics. So in this case, the number of participants was 298. It shows you the median, the mean, the maximum, and standard deviation. So that's simply how you perform your descriptive statistics using SPSS. You can decide to also explore the remaining statistical analysis, but this is simply what happens, and you should save your contents whenever your analysis is complete. The next thing we'll look at is the correlation. So with correlation analysis, it's used to determine whether two variables are related in any way. So you simply come to analyze and then correlate. So what correlation will tell you is, for instance, does age increase body weight? Or is there a relationship between the hours of study and examination scores? Or is physical activity associated with your weight? So correlation will simply tell you whether a relationship exists between variables and whether it's positive or negative and how strong the relationship is. Remember that correlation does not mean one variable causes the other. It only tells you whether they move together. So you simply go to analyze and then correlate. Then you can select. Once you do so, assuming you want to find out what the relationship is between the gender and pocket money, you simply select these two variables. And then, as in the next step, you can decide to analyze. So it tells you what the relationship is between these two variables. It also tells you how strong the relationship is. It can either be highly positive, which is indicated by the color codes in each column. It can also be positive, which is indicated as shown in this particular data set. So this simply just helps you look at what the relationship is between the variables that you have. Then the next thing is the regression analysis. So with regression analysis, instead of simply asking whether variables are related, regression helps us understand whether one variable can predict the other. For example, can age predict blood pressure, or can study hours predict examination scores, or can how much you eat predict how much you gain? So with regression, it's widely used in research because it helps identify factors associated with an outcome while estimating the strength of those relationships. So it is found under the same analysis panel that we selected earlier. So how do you choose the right analysis? A simple way is to remember this. First of all, we have the descriptive analysis, which tells you about your data. And then we have correlation, which tells you a measure of the relationship between variables. And we have the regression, which will predict one variable using one or more other variables. So choosing the correct analysis would depend on your research question and the type of data you've collected, and most importantly, your objectives. So here we now have an example of a study, and we can access the Excel sheet in the description below. So this is what we'll use for the data analysis. An important thing to note is that before you begin analyzing your data, you need to have in mind what your objectives are, because this is what will guide the type of analysis you need to have in a particular research. So for this particular research, we are looking at the effect of study hours on academic performance. So some of the tests that we'll use include the same correlation we talked about, the regression analysis, descriptive statistics, of course. We'll also look at frequency distribution, some linear regression, some multiple linear regression, as well as one-way ANOVA. So to begin with, you'd always want to start with descriptive statistics. And to achieve that, you simply click on Analyze, Descriptive Statistics, and then we'll click Descriptives. So in order for us to have an idea of what our dataset looks like, we need to put in all of our variables in the variable box. In addition to this, we also want to modify the options. What we are particularly interested on is the mean, which is already selected, the standard deviation, as well as the minimum, the maximum. Then you can click continue. Once that is done, you can click OK, and a dialog box will pop up showing you the output. So this is what the output looks like. And that is simply how you perform your descriptive statistics. The next thing we'll be looking at is frequency distribution. The purpose of this test is to summarize your categorical variables by showing the number of percentages and observations in each of your categories. So to achieve that, you simply click Analyze. You go on Descriptive Statistics again, and then proceed to Frequencies. In this case, we're going to move gender as well as year of study into our variable box. You have to ensure that you select Display Frequency Tables. Then once that is achieved, you can click OK. So all the information appears on one dialog box. As you can see, this is the previously performed statistical analysis, and this is the frequencies for the gender and year of study. The next thing we'll look at is the correlation analysis. So the purpose of the correlation test, as we discussed earlier, is to determine the strength and the direction of the relationship between two continuous variables. So in this case, we'll click on Analyze and Correlate. We'll move study hours per day and academic performance, because those are the two major variables we want to look at for this particular study. So you can click on study hours per day as well as academic performance. Then once that is done, you can click OK. And there you have your output. The next thing we're going to look at is a simple linear regression. Now, a simple linear regression is used to examine whether one independent variable predicts a dependent variable. So in this case, we're simply going to go to regression, and then we'll go to linear. Once we are here, remember, we are going to move academic performance to the dependent box because that's the dependent variable. So academic performance goes here, and then we're going to move study hours per day to the independent variable box. So study hours per day goes here. The next thing you want to ensure is estimates, model fit, and confidence intervals are selected. So in order to achieve that, you simply go to Statistics and click Estimates. You also want to click Model Fit. You also want to click Confidence Intervals, which is this one. And then once you select, you click Continue and proceed with the analysis. And this is the output for that particular regression analysis. The next analysis we want to perform is the one-way ANOVA. The purpose of this test is to compare the mean values of a continuous variable across, let's say, 3 or more independent groups. So in this particular study, here are the variables that we're going to use for the ANOVA test. So you simply go to Analyze, then you go to Compare Means. On Compare Means, you want to select one-way ANOVA. Then in the dependent list, we're going to move academic performance. So academic performance comes here. Then you move your year of study into factor box. So year of study goes to the factor box. Once that is done, then you can click OK, and here we have the output. The final analysis we're going to conduct is a chi-square test of independence, and this test is simply used to determine whether there is an association between two categorical variables. So in order to achieve this, you simply click Analyze, You click descriptive statistics and then click cross tabs. You want to move your study hours category to the rows box. So study hours goes to the rows box. And then you want to move gender or any other categorical variable to the column box. So in this case, we're going to move gender to the columns box. Once you achieve this, you click statistics. Once you're here, tick chi-square. And then proceed. Click cells as well. Select observed, expected. You can also select rows under percentages, as well as columns. Once this is achieved, you can click continue and you can click OK. And this is what your output looks like. So this is simply how you expect your output to look like from start to finish. So in the next video, we'll be discussing how to interpret data based on what these tables produce.